Alright, so in our previous problem, we looked at taking barium chloride solution and iron 3 sulfate solution and mixing them together and producing a barium sulfate precipitate and iron chloride remaining in solution. So I summarized that all up here. Barium chloride plus iron 3 sulfate gives us barium sulfate and iron 3 chloride. The problem gave us 50 milliliters of 0.200 molar barium chloride, which gave us 0.0100 moles. And it told us that we had 200 milliliters of 0.100 molar iron 3 sulfate, which gave us 0.0200 moles. What we want to do now is we want to find out what the concentration of all the ions are going to be left in the solution after the reaction is complete. And remember we said that barium chloride was the limiting reactant. But in reality, it's really just the barium ions that are going to limit how much precipitate we can form. The chloride ions are going to stay as ions in solution. They're spectators. The iron ions are going to remain as spectators because they're not part of forming the precipitate. And the sulfate ions are going to form the precipitate, but there's going to be some sulfate left over. And we want to find out what the concentration of all of the ions are after the barium ions have been completely consumed. So let's look at the barium chloride part first. Okay, if we have barium chloride and we dissolve it in water, that's going to give us barium ions and chloride ions. Well, we had 0.0100 moles of barium chloride, so that's going to give us 0.0100 moles of barium ion and twice that of chloride ion. So that's going to give us 0.0200 moles of chloride ion. So from here we can find out what the concentration of barium ions and chloride ions are after the reaction is complete. These brackets mean concentration or molarity. Now the barium ions are the limiting reactant, and when we say something's the limiting reactant, it means it gets used up. So its concentration is going to be 0. But there's going to be chloride ions left in the solution. So we want to calculate the chloride ion concentration. None of it reacts, so 0.0200 moles divided by the total volume. We added 50 milliliters to 200 milliliters. That's going to give us 250 milliliters, or 0.2500 liters. So the concentration of chloride ions after we mix the two solutions together will be 0.0800 molar. All right, so now let's look at the iron sulfate. So we've got iron 3 sulfate. That's going to break up into iron ions and sulfate ions. Now when we looked up here, we calculated the iron sulfate concentration to be 0.0200 moles. It's a 1:2 ratio. So for iron ions in the original solution, we have 0.04. And for sulfate ions, we have 0.06 moles. Now, the iron ions are not part of forming the precipitate, so they're also spectator ions. So if we want to calculate the concentration of our iron 3 ions, we would take 0.0400 moles, that's how much we had, divided by the 50 plus 200 milliliters, or 0.2500 liters, And that's going to give us a 0.16 molar iron ion. The last ion we have to think about is the sulfate ion. And there's an issue with the sulfate ion. This is how much sulfate ion we started out with. But some of it's going to react with the barium ion to form a precipitate. We need to find out how much of the sulfate ion reacts, how much sulfate ion is left in excess, and then we can calculate the concentration. So the barium ions from the first solution are going to react with the sulfate ions from the second solution and precipitate as barium sulfate. So if we look originally, we had 0.0100 moles of barium ion and 0.0600 moles of sulfate ion. So here and here are going in here and here. Now the balanced equation tells us for every 1 mole of barium ion, 1 mole of sulfate ion is going to react. So if all of our barium ion reacts, 0.0100 moles that reacts, we don't have any barium ion left. And that makes sense because it's the limiting reactant. If it's a 1-to-1 ratio, it means that 0.0100 moles of sulfate ion reacted. We had 0.06, now 0.01 reacts, so we're going to be left with 0.0500 moles of sulfate ion unreacted, or left in the solution. It's in excess. We can calculate the sulfate ion that's left in excess in our solution. We would take 0.0500 moles of sulfate, divide it by the total volume, which is still 0.2500 liters, and that's going to give us 0.200 molar sulfate ion left in excess in the solution. So barium sulfate is produced when barium chloride and iron 3 sulfate react together. But in reality, it's the barium ions and the sulfate ions that form this precipitate. The barium ions are the limiting reactant in forming that precipitate, so we don't have any of it left in the solution. Some of the sulfate ions react with the barium ions, but some are left in excess, so we can find out how much sulfate ion is left over in solution. And the chloride ions and the iron ions are spectators. The amount of those ions stays the same because they're not forming a precipitate, but they're going to be diluted because we're adding two solutions together.